All right, everyone, we are on to our third example for our algebraic techniques. So let's take it to the limit one more time. We have x squared plus 4x minus 12. We have x squared minus 2x on the bottom. We're looking for the limit as x approaches 2. But this one's unique in a way. I don't know if this is in our notes, but may as well throw this in there. When you have a function like this where we have our x's on top, we have x's on bottom, we've talked about vertical asymptotes, we've talked about holes. One thing, again, I don't remember if we've talked about this in class or where you could have learned this from before, but even if it's new information, when you have an equation that has the same exponent top and bottom, so in this case x squared and x squared, when you have something like that, that is a tip off that you have a horizontal asymptote as well. So graphically, we need to figure out what kinds of asymptotes and holes we have. So the first thing we need to do is actually factor this. So let's factor the top first. We have two binomials because we have x squared. The minus means we have opposite signs. So x plus a number, x minus a number. And then, let's see, we need factors of 12 that get us to 4. So we've got 12 and 1, 6 and 2, 4 and 3. Well, 4 and 3 won't get us anywhere. 12 and 1 won't get us anywhere, but 6 and 2 will. In fact, I'm going to keep our 6 as our positive because we end with a positive 4. See what happens. So x squared minus 2x, but plus 6x. That gives us plus 4. And then minus 12. All right, so there it is. We factored it. The bottom, though, we can also factor the bottom. And that's just simply saying, you know what, we can take an x out of both terms. So I'm going to pull an x out and then say x times what gives us x squared minus x times what gives us 2x. And there we have it. So just like the other two examples, let's see, if we have a term in the bottom that can be canceled by a term in the top, we have a hole. In fact, our hole here is at -2. But we have a second term, right? We have x all by itself. That is its own term. That factor or that term is not canceled by a plain x on the top. So what we have going on here, we actually have a hole at -2 and a vertical asymptote at 0. So let's see graphically what that looks like. Let's see, -2, going along, we come up to -2. It's Friday, I'm sorry. I can't figure this out. Not that I can't figure it out. I keep saying -2. So let's pretend like that didn't happen. What I meant to be saying is we're taking our limit at 2 because x minus 2 needs a 0 at 2. How about that? So let's rewind. I'm not going to edit that. I'm just going to simply pretend like I never said that and we've been looking for the limit at 2 this whole time. So as we approach 2 from the left, as we get 175, 177, 1.8, we get to 2, and what happens? Oh, there it is. We're undefined. So we did confirm. Graphically, we see it. It looks like it's continuous, but if you actually click on 2, we do have a hole there. Okay. The vertical asymptote, as mentioned, that was at 0. So there's our vertical asymptote. Now, I also mentioned before, I said if we have the same power or exponent on the top and the bottom, we have a horizontal asymptote. And that's what that is going to be right here. What's cool about those is you can find that a horizontal asymptote is just simply found, well, first of all, it's the line y equals some number. That some number is found by taking the coefficients of the leading terms. So let's do that real quick. Our leading term here, x squared, the coefficient's 1. bottom, the leading coefficient, so x squared, has a coefficient of 1. So the line y equals 1 over 1, or just the line y equals 1, is our horizontal asymptote. And as you see, here's our line y equals 1, and that is our horizontal asymptote. That kind of, again, a side note, but for future reference or as a reminder, if you've learned that before, when you have that happen, we have horizontal asymptote. Going back to the algebra side, we've been trying to figure out how to find the limit at x equals 2. So if x is 2 and we leave it in this form, we're not going to be able to do a direct substitution. But as examples 1 and 2 showed us, I can take x minus 2 divided by x minus 2, it reduces to 1. Our graph ends up really looking like x plus 6 over x. So if we do this and we say, oh, well, let's do direct substitution. So the limit as x is going to 2 of x plus 6 over x. Well, if direct substitution works, we can say 2 for x, that's 8. 8 divided by x is 2. 8 over 2 is 4. Okay, well, let's check that graphically. So here we are, in fact, here. I'll go like this. I'll do the table method, sort of. We'll go to x is 2, undefined. Okay, well, that's not good. So we find as it approaches it from the right, so 2.001. All right, well, that value just off of 2 is almost 4. We could also say 1.999999. As you see, I add 9s. My limit is getting closer to 4. So graphically, we see as we are approaching, it looks like we're headed to 4 right here, right? If you use substitution that way, however you want to look at it, we have proven that our limit is in fact 4. So going back, our final answer, limit as x approaches 2 is 4. So we box that in. And that, in a nutshell, that's how you go about using algebraic techniques. So even though the graph x plus 6 divided by x looks similar, right, let's check that actually. X plus 6 over x. I'm not sure why it has the same color. But as you see, as I turn this graph on and off, it is the same graph. So algebraically, we manipulated it, and all we did was we got rid of the hole at x equals 2. But in doing that, we can then go back to the easy method of finding limits using direct substitution. So hopefully all these have helped. I will actually be working towards getting some videos of the practice problems also. That didn't really work. So hopefully I can get all these practice problems up and walked through so that you can actually see the practice problems done, as opposed to just looking at the answer key and saying, well, I didn't get the answer, but I don't know how to get the right answer. So be looking for those on my YouTube channel, which all of these videos that you're watching, you can just go to my channel. I've got a playlist for honors pre-calc, and you can find these practice problems down there. So anyways, good luck. If you have questions, you can email myself or your own honors pre-calc teacher if you would like. So thanks.